Hi there and welcome to our next lesson in our C3 topic on chemical economics, and today we're going to be looking at atom economy, and this is where we use a little bit of maths to work out whether a chemical reaction is viable to do or not, and we're looking really at the industrial terms of whether it's worth doing the chemical reaction or not. Anyway, I will see you at the end. Okay, so let's have a look at our objectives for today's lesson on atom economy. So by the end of this lesson you should know and understand how the mass of certain products compare with the total mass of a reaction. Now, atom economy is the calculation of how much product is actually wasted during a chemical reaction. Now, to calculate it we can use this equation, where the atom economy is equal to the mass of the desired product or products over the total mass of all the products. Now, in order to get a 100% atom economy, you need to have all of the products being a desired product. So if we look at one of the reactions we've seen before, where calcium carbonate will decompose to make calcium oxide and carbon dioxide, if the calcium oxide and the carbon dioxide is desired products, then we will get a 100% atom economy. Now, the highest atom economy rates are when we have the least amount of products that are wasted. Okay, so here's our problem then that we're going to work through. Limestone is heated to make a useful product of calcium oxide and a waste product of carbon dioxide. What is the atom economy? Now, the information we've got here in the question, we've got the MRs of the reactant and the MRs of the two products. So the first thing we're going to do is we're going to set out our equation that we're going to use. So we have the atom economy is equal to the mass of the desired product divided by the mass of the total products. So now what we'll do is we'll substitute the numbers. So the mass of the desired product, the calcium oxide, is 56, and then the mass of the total products is the 56 plus the 44, which, as we know because of the conservation of mass laws, will be 100. So if we do 56 divided by 100, we come up with an atom economy of 56%. Now, what you might be asked to do is decide whether 56% is a decent enough economy rate, as should it be any higher, should it be any lower. Now, normally a typical yield for atom economy, you're looking at 95% atom economy to be a very effective. 56 might be on the lower end, but it still might be the most effective way of actually completing a chemical reaction. Okay, now the reason we use this is similar to the percentage yield. We're looking to reduce any unwanted products and to make the process more sustainable. A drug has a MR of 568. The drug can be made by two methods. Method 1 makes a waste product with a MR of 68. Method 2 makes three waste products with a total MR of 56. Which has the lowest atom economy? Now, what I'd like you to do is I'd like you to pause the video. I'd like you to do the calculations for both, and when you've done that, come back and we'll repause or unpause to get another, or go through the answer. Okay, so here's the answer you should have. The atom economy for method 1. Okay, so the atom economy is equal to 568 divided by 568 plus 68, which is 636. And that gives an atom economy of 89.3%. Okay, so for method 2, we'll do the same equation. Okay, so 568 divided by 568 plus 56 gives an atom economy of 91%. Now obviously because of this we've got method 2, even though we produce 3 products we're getting a higher atom economy. So in terms of atom economy, method 2 is the better method to use. Now you might need to explain why. So why is method 2 the better way to, or better method to use? It's very simple. It's although you have 3 waste products in terms of the atoms that you're wasting only 9% as compared to the nearly 11% on the second one. Okay, so let's have a quick review on what we've looked at today. We have looked at atom economy and how to calculate that using the mass of the desired product divided by the mass of the total products. We've looked at the reasons why we need to do that to make it a sustainable reaction and to reduce the waste, and we also looked at a couple of examples. Again, you might be required to look at some data and calculate whether a method or which method is the most viable. Anyway, I hope you enjoyed this and I'll see you next time. Bye bye.